So lesson 5.3, remember 5 means the chapter, 3 means which lesson in that chapter. And we're going to talk about the angles of triangles. Today's date's 3/11. So again, in the inquiry lab that you guys worked on yesterday with the substitute, where you took 3 different shaped triangles, ripped their 3 corners off, put them together point to point, found out that they made a straight angle. And we talked about, so it looked something like this, where you had a piece here with angle 1, and you had a piece that ended up here, and that was your angle 2, and then you had piece here, oops, sorry, that doesn't look right, piece here, that was your angle 3. And those 3 angles formed a straight angle, was equal to the measure of angle 1 was plus the measure of angle 2 plus the measure of angle 3, and that will equal 180 degrees because that's what a straight angle equals. And so what you are able to take from that, if I put that triangle back into its proper shape, what that tells me is the sum of the angles, of any triangle, because we did 3 different shapes. We did one that looked similar to this triangle. We had an obtuse triangle where the largest angle was over 90 degrees. And then we had what we call a right triangle where one of the angles was exactly 90 degrees. So the sum of the angles of any triangle is equal to 180 degrees. Okay? And let's see, I think they give a name to it. In geometry class, they called it the triangle angle sum, but now this one's called the angle sum of a triangle. So you guys have a new name for this one. So it's the angle sum of a triangle. So knowing that the angle sum of any triangle is 180 degrees, that can help me figure out a missing measurement. If I know 2 of the 3 angles of that triangle, then I can figure out the 3rd one by using this formula, basically, that all 3 of them have to equal 180. Okay? So let's talk about an example that the book has. So if you want to, open up to page 389. We're going to go ahead and kind of walk through this example. I'm going to replicate it onto the page here. We have line M, line N, line M, line N, and then we've got line R. We have line P, and then we have various points of intersection. So I'm going to color them out. So this point of intersection is A, this point of intersection is B, this point of intersection is C. Now I'm also going to number out some angles. So we had angle 1, angle 2, angle 3, angle 4, and angle 5. And then the last thing I want to note is that line M and line N are parallel. Now, the relationships we talked about on Wednesday between angles that are alternate interior, corresponding, alternate exterior, they only ring true if the lines are parallel. So that's our proviso for what we're studying in this chapter, is all of the lines that we're studying have to be parallel in order for us to draw further conclusions. Okay? So all those relationships we talked about on Wednesday hold true when the lines are parallel. Okay. So looking at this, what could you tell me about angle 1 and angle 2? According to what we've studied so far, what do we know would have to be true about angle 1 and the measure of angle 1 and measure of angle 2 if those lines M and N are parallel? What kind of angles are they? They're not straight angles. Angle 1 and angle 2 are not straight angles. What kind of angles are they? Savannah? They're not corresponding angles. They're not in the same position. One is facing to the left, one's facing to the right. So that's not corresponding. Ladies and gentlemen, you got to know the basics. Every day what we talk about needs to stay in that brain for the subsequent days. Okay? What kind of angles are angle 1 and 2? Okay, they're not parallel lines because they're angles. Minimum requirement, ladies and gentlemen, would be looking back to your notes on Wednesday and trying to figure out what angles would look like that fall between two parallel lines but are on opposite sides of the transversal. Nico? They're not vertical. They don't share a common endpoint. Granger, you think you got it? Are they outside the parallel lines or between the parallel lines? They're interior because they're between. These are alternate interior angles. All right, I'm going to require an additional homework assignment. You need to make flashcards for the different names of the angles, and you're going to present those to me on Monday because there's no reason that you cannot tell me those are alternate interior angles if you had properly studied these. And if it takes flashcards to do it, then that's what it's going to be. So that will be an additional homework for you for tonight, and I will assign that to all the classes. According to our notes, if the lines are parallel that form those alternate interior angles, what do we know is true about the measures of angle 1 and angle 2? Okay, Melissa. So we can assume, because we have alternate interior angles that fall from parallel lines, the measure of angle 1 has to equal the measure of angle 2. Okay? Now, what would be true about the measures of angle 3 and angle 4? So what would we identify? What types of angles are angle 3 and angle 4? So again, you guys are looking in your book. You don't have to look up here. You can look at your book. Angles 3 and angle 4, how would we describe those angles? So again, our choices are alternate interior, alternate exterior, corresponding angles. We do have vertical angles, and we do have angles that are supplementary. The last two were studied last year. Okay, Maddie. They turn out to be alternate interior as well. They're between the parallel lines. They're on either side of the transversal. So these are alternate interior angles. So what would be true about the measures of those two angles if they are alternate interior angles formed by two parallel lines? Savannah? Their measures would have to be equal. So measure of angle 3 equals the measure of angle 4. Okay? So the question then asked is, what kind of angle is formed by angle 1, angle 3, and angle 5? What kind of angle is formed by angle 1, angle 3, and angle 5? Okay, how did we describe that angle? Giselle, what kind of angle do angles 1, 3, and 5 together form? You can just look at it and see what kind of angle it forms. It's in our notes from Wednesday. That doesn't describe what we got going on here. It's not asking what is angle 1, what is angle 3, what is angle 5. It's what are those three together form. That's what it's asking. And remember, alternate interior angles, alternate exterior angles, corresponding angles are referencing 2 angles at a time. We've got 3 in this particular case. So what could it be? Oh, we wrote it down, folks. We should know it. Emily? It's a straight angle, right? It makes a line, so it's a straight angle. And what did we write down in our notes that is review from last year? What does a straight angle actually measure? Say again? 180 degrees. So that says the measure of angle 1 plus the measure of angle 3 plus the measure of angle 5, because it's a straight angle, should equal 180 degrees. Now, I am going to correct something I just heard. Somebody told me, or I heard the word supplementary used. Okay, we can't use supplementary in this situation. Why not? What's the stipulation, the requirement to have supplementary angles? What did we write down in our notes? Look carefully at your notes from Wednesday under supplementary angles. What was the definition that we wrote? Brooke, you got it? What's it say?
2 angles whose measures add up to 180.
Say that real loud.
2 angles whose measures add up to 180.
Supplementary angles are 2 angles that add up to equal 180. We have 3 angles that add up to equal 180. By definition, we cannot say those are supplementary. Okay, we can't, because the definition says it's only 2 together that make up 180 or a straight angle. Okay, so let's look at what we got. I have measure of angle 1 plus measure of angle 3 plus measure of angle 5 equals 180. But what did we say that measure of angle 1 also equals? What did we write down that the measure of angle 1 equals? Yeah, so I could substitute in for measure of angle 1, measure of angle 2. Okay? What did I say, or we write down, that the measure of angle 3 was also the same as? It said 4, right? So let's change that. So 3 is the measure of angle 4. So basically, I can rewrite the measure of angle 1 plus the measure of angle 3 plus the measure of angle 5 equals 180 to the measure of angle 2 plus the measure of angle 4 plus the measure of angle 5 equals 180. Now, look at the measure of angle 2, the measure of angle 4, and the measure of angle 5. What do they form? They form a triangle. So we just concluded, we proved, this is a geometric proof, guys, that you just helped me with. The sum of the angles of a triangle equals 180 degrees. That, ladies and gentlemen, is an introduction to geometric proofs. Okay? It's based on logic. It's based on vocabulary. It's based on definitions. It was the definition of alternate interior angles and their measures being equal. It was the definition of a straight angle whose sum is 180 degrees. And then it was using a property called substitution. You guys just did a ton of geometry in a little bit of time. But what was our pitfall? We didn't know our vocab. We don't recognize alternate interior angles, if we don't recognize straight angles, if we don't recognize corresponding angles, and so on, we're going to struggle with any kind of geometry. And you have a whole course of doing this. Vocabulary is extraordinarily important. We had this conversation on Wednesday. You need to know the vocab. Okay, so we got that one down. Let's do a couple of examples. So I would do this on the other page. Keep one page just for notes and one page for examples. And so our examples, we're going to do 2 different kinds. One, a more simple kind. One that's going to make us think a little bit harder. And what we're going to do is look for a missing angle, okay? So I'm going to draw you a picture. Let's see, the directions are just going to say, find the value of x. So it's not going to necessarily have a picture, and that's really true about geometry class. A lot of times they give you words, so the first thing that we do is draw a picture to go with it, because geometry is very visual. It really helps us out. So it says in triangle XYZ, if the measure of angle X, oh, actually, this one, we'll do it this way. If the measure of angle X equals 72 degrees, and the measure of angle Y is equal to 74 degrees, and the measure, of angle Z is equal to X, what is X? So notice there's two different X's. There's a large X, capital, and there's a small x. We're looking for the small x. Okay? So what kind of triangle do I know for sure I could not draw? Nico? Yeah, I couldn't do equilateral, that's for sure, because what would be the measures of the angles if it was equilateral? How much? Yeah, and what would they be if all three of them have to equal 180 and each of the angles has to be the same amount? What would it be? 60, exactly. So those are over 60 degrees, so it can't be that kind of angle. What other triangle? What other kind of triangle could it not be? Yeah, it can't be a right triangle because what would be the third angle's measurement? 90. But 72 and 74 and 90 give me well over 180, so I'd have to throw that one out too. So it's just going to be some random looking triangle. It actually could not be an obtuse triangle either because of the fact that I've already got those two angles add up to equal 146. So the missing angle can't be over 90. So I'm just going to draw a picture. Now, do we have to be super duper accurate when we draw a picture? No, we're just writing in our labels and then adding in numbers and then visualizing it, and then we realize, oh, I can do this. So when they said in the very first phrase, in triangle XYZ, where does the X, the Y, and the Z represent in that triangle? What does the X, the Y, and the Z represent? Pardon me? Doesn't represent a line. Not, it does somewhat, but it's not really what those letters represent. Savannah? Yeah, and again, this is me not knowing what you guys have gotten or haven't gotten, and I think this has been covered. These are what are called the vertices of the triangle. So the endpoints of each of the sides is called a vertex. And a vertex isn't just in triangles, it's any kind of shape that has a point to it. So an angle has a vertex, okay? And then it has two rays coming out of it, and it forms some sort of angle here. We'll call it 35 degrees, okay? So a vertex is where two endpoints meet. So any polygon shape you have, all those points are called vertices. And that's how you name a triangle, is by the three vertices, okay? So I'm going to add in the numbers that they told me. So let's see, the measure of angle X is 72. The measure of angle Y is 74. And the measure of angle Z is X. So what do we know is true about the measures of the angles of a triangle? They equal 180. So I can use that angle sum of triangles, 72 plus 74 plus X has to equal 180. And now I just solve it. How do I solve it? Same way I would solve anything else. I would look for like terms on a side, and I combine them. That means do the math that's shown. So I get 146, and then I still have plus x equals 180. What do I do to get the x by itself? I'm hearing whispers. What do? I subtract that 146 from both sides. Okay, now, remember you're not in second grade learning how to subtract three-digit numbers for the first time like my daughter. And you're not going to tell me 0 take away 6 is 6, right? Because you know what we need to do the subtraction in the ones column. Susie?
You need to take one from the
Yeah. So what we do is this is called renaming. We take a 10 and we rename it as 10 ones. And then we add the 10 ones to what we had in the ones column, which was nothing. So now we have 10 ones plus nothing is 10 ones. So now I can do this math. 10 take away 6 is 4. And I took away 110, so now I'm down to 7. Take away 4 is 3. So my answer would be that missing angle is 34 degrees. Okay? The second problem says the measures of the angles of triangle ABC are in the ratio of 1 to 4 to 5. What are the measures of each angle? Okay, very different than the last one where they gave us 2 of the angles and we had to figure out the third one. This one actually doesn't tell us what any of the angles measure. What it gives us is a relationship between the angles. So remember ratios? Ratios are just comparing numbers. And what they do with a ratio is they take the numbers and they reduce them to lowest terms. So when I reduced them by their greatest common factor, I was left with a 1, a 4, and a 5. So the trick to solving this problem is how do we define our 3 angles? Okay, so what we're going to do is we're going to take those ratio numbers. And the reason why I'm going to go through this is you have at least 1, if not 2 of these problems on your homework. I'm going to take my ratios and I'm going to write them vertically. Now the angles did not measure 1, 4, and 5 because that would add up to 10, and that certainly doesn't equal 180. So what I need to do is to figure out what I reduced them by. So I'm going to let that value that I reduced them by be x. And so this means this is the measure of the first angle. 4x would be the measure of the second angle. And 5x would be the measure of the third angle. Okay, so what do we know is true about the measures of the angles of a triangle? What do they equal? They equal 180. So I'm going to take those 3 angles and I'm going to add them up. So I have 1x plus 4x plus 5x equals 180. Now, these are called like terms, right? Because they have the same variable with the same exponent. So I'm just going to take the coefficients and add 1 plus 4 plus 5. And what does that give me? 10. So now what I have is 10x equals 180. So how do I get x alone? I'm going to divide by 10, right? Do inverse operations. And I get x equals 18. Now, is that the measure of an angle? No. Well, kind of technically is. But the reason why it's not, it's just what I reduced all my angles by. So to figure out what my angles actually equal, I'm going to substitute this, go a little further, into the 3 definitions. So for the first one, I have 1 times 18, which equals what? 18. So one angle was 18 degrees. The next one is 4 times the x value of 18. What's 4 times 18? Try again. Not 64. 72. Good. And then the last one is 5 times 18. Oh, look at that. What kind of triangle do we have? What do we call a triangle with an angle of 90? We ended up having a right triangle. That's interesting. And that is what they want you to come up with. Okay? So let's talk about our triangle again. Let's go back. So angle 1, angle 2, and angle 3 are called interior angles because they're the inside of the triangle. Okay? Now, what if I took one of the sides and I extended it? And I create a new angle. And I can do that for each of my sides. I can extend and create a new angle on the outside. I can extend and create a new angle on the outside. So what do you think we call angle 4, angle 5, angle 6, if angles 1, 2, and 3 are called interior angles? What do you think we're going to call angles 4, 5, and 6? Exterior angles. Very good. Okay. So, what do we call angle 3 and angle 4? What kind of angles are they? Nico? They form a straight angle, which means what do they have to equal? They equal 180 degrees. And if I have two angles that add up to equal 180, what's another name we can call them? Not straight. Oh, there we go, supplementary. Okay, so what I'm going to do is give some arbitrary numbers for my angles 1, 2, and 3. Let's call angle 1, let's make him 40. Let's make angle 2 55. Let's make angle 3, let's see, 85. So if angle 3 is 85, and I add that to the measure of angle 4, and you told me they equal 180 because they form a straight angle. And I wanted to figure out what the measure of angle 4 would equal. And I get 95 degrees. All right, that's cool. So I'm going to label that in here. This is 95. And let's do the same thing at the top here. Let's say we know that the measure of angle 1 is 40 degrees. And I want to add to it the measure of angle 5. It forms a straight angle, so it equals 180 degrees. So if I want to figure out what measure of angle 5 is and solve it, what do I get? Say again? I get 140 degrees. Okay, let's keep going. We got one more here. We've got a measure of angle 2 is 55 degrees plus the measure of angle 6. And we know they equal 180 because that's a straight angle and they're supplementary. So if I subtract 55 from both sides, I get that the measure of angle 6 equals what? Say again? 125 degrees? So let's just take all of those exterior angles and let's add them up. So remember, those are angle 4, angle 5, angle 6. So angle 4 was 95, Angle 5 was 140. Angle 6, the measure of that was 125. So add that up on your paper and tell me what you guys end up getting. What you guys get? That will always be true. So the exterior angles of a triangle, the sum is equal to 360 degrees. Always. Okay? Now, let's look at one more thing. So I'm going to go to a new picture. This one's getting pretty darn cluttered. So I'll wait until you guys are ready. Okay, so I'm going to draw a little cleaner version of that picture because that one got pretty messy. So I'm going to start with a triangle. And I'm going to number my angles. I'm going to draw in my exterior segments. So I've got my exterior angles. And I want to give you one more vocab word, and that is remote interior angles. So in remote interior angles, that's going to be two angles, or it's the two angles not adjacent to an exterior angle. So let's just identify. So if I've got angle 5 is the exterior angle, what would be considered the two angles that would be remote interior angles? So interior means they have to be inside the triangle, and they cannot touch angle 5 at all. So what two angles inside the triangle do not touch angle 5? 1 and 2. So angles 1 and angle 2 are the remote interior angles to angle 5. Okay? And so if I have angle 4, what would be the remote interior angles to angle 4? Angle 2 and angle 3. And what if I wanted to figure out the remote interior angles for angle 6? What would they be?
1 and 3.
Angle 1 and angle 3. Okay? Now, let's look back, and I'm going to take numbers from just one of our scenarios. So let's do an exterior angle as 95. So we'll say this one's 95. And let's look at the angles that were opposite. So we had angle 1 and angle 2 in that picture. So for us, it would be 40 and 40 and 55. Okay, so I'm just stealing numbers from our diagram before. So what do you think is interesting between, so we're looking at this relationship. So what's the measure of angle 4?
95.
95. And what was the measure of angle 2? 40. And the measure of angle 55? I mean, measure of angle 3 is 55. Okay, so look at your numbers, 95, 40, 55. What do you notice? What do you guys see? You got to say it loud enough for me to hear. Okay. Is about all I heard. Granger, what were you saying? Okay. The three of them equal 180. That's interesting. But how does the orange compare to the green? Savannah. Yeah. If I add those two remote interior angles, they should give me the same answer as the exterior angle. Okay? So that is an important idea to get, that the measure of an exterior angle is equal to the sum of its two remote interior angles. So in our case, the measure of angle 4 was equal to the measure of angle 2 plus the measure of angle 3. So, to my list that I'm making vocab cards for, we have alternate interior, alternate exterior. We have corresponding vertical angles, supplementary angles, straight angles, remote interior angles, the sum of the measures of a triangle, the sum of the measures of exterior angles. So that's 9 cards you guys are going to come up with for Monday. Okay, and I'll collect those.